Hi and welcome everyone. Welcome back to the course of Computer Networks. In today's lecture, we will talk about a new topic called Multiple Access Protocols. So what is topic called multiple access? So first, we know that multiple access is a functionality related to data link layer, MAC layer, and multiple access protocol is really multiple access topic, very comprehensive and deep and thorough and wide topic that it involves so many techniques, so many methods, and different types of ways of accessing the channel. So multiple access protocols can be divided into three main types. We have the random access protocols. Example on these protocols, we have the Aloha protocol, CSMA protocol, CSMA CD protocol, CSMA CACA protocol. So this CSMA called carrier sense multiple access, CD collision detection, CA collision avoidance. We have also the controlled access protocols. Example of this kind of protocols, we have reservation, polling, token passing. We have the channelization protocols. Example on this, FDM, frequency division multiplexing, time division multiple access, CDMA, which is code division multiple access. We have also the OFDM, orthogonal frequency division multiple access. We have the NOMA, non-orthogonal multiple access. All these are related to channelization. So, for example, in Aloha, carrier sense multiple access, multiple access, collision detection, collision avoidance, all these techniques are used in Wi-Fi networks, Ethernet networks. Controlled access protocols are used mainly in Ethernet, wired. Channelization protocols mainly are used in cellular networks, mobile networks. Your mobile phone is using them when it's connected to 4G or 5G or 3G. For example, TDMA with FDMA is 2G GSM. CDMA is 3G technology. And OFDMA is 4G and 5G. NOMA is a new technique, a new way of accessing the channel, which is not yet used, but it's in the research phase. Researchers are working on it. So as you can see, all networks, including cellular and Wi-Fi, are using combination of these. But before we get started with this, let's understand why we need multiple access. Why is that? Why is it needed? So let's say the following. If there is a dedicated link between the sender and the receiver, dedicated means reserved link between the sender and the receiver, then the data link control layer by its own is sufficient. There is no need for other things. However, if there is no dedicated link between the transmitter and receiver, there is no dedicated link present between the transmitter and receiver, then multiple stations, multiple devices can access the channel simultaneously at the same time. Now, from signal processing perspective, communication perspective, and computer network perspective, what will happen if multiple stations, without organization, without coordination, start talking at the same time? What will happen? Let's just give you an analogy for this. Let's say we have 10 people in a room, and all these 10 people are talking to each other at the same time, loudly. What will happen? You can barely understand any one of these people because they are shouting, they are interfering with each other, and causing interference, which prevents you from sending your message correctly to your intended receiver. And this is the idea of multiple access. You have multiple users, you have multiple devices, and you want them to talk to each other effectively. How are you going to do this? You can do this if you set certain protocols. What kind of protocols you can set? You can say, if someone is speaking, nobody is allowed to interrupt him or her. Just wait until he finishes. How do you know that he finishes? once you stop hearing any voice from him or he stopped talking, you obviously know that he's not sending or he doesn't want to talk or add any more things. And then you look at the others and you see nobody is intending to talk, then you talk. By doing so, you make sure that whenever you start talking, nobody interferes with you if everybody applies the rules. So multiple access protocols are basically rules that can organize and coordinate the access of the channel. Who's now right to speak, who's gonna send message, who's now turn to send his data, to say whatever he wants, and the remaining ones should be listening when he talks. That's how you make sure there is minimal interference and the messages can be transmitted and received correctly while utilizing the bandwidth efficiently. This is the analogy, but in computer networks, things are a little bit different because computer networks are not shouting, are not talking, they are sending signals. These signals also, although they are not shouting, the way we cannot really feel the interference, but the interference also happens on the signal level, or in the air. When two devices send their signals, their frequencies, at the same time, they will collide. And this will cause collision. And once your packets are collided, you need to your packets are gonna be lost, and you need to retransmit them again and recorrect your messages, which is bad. It's gonna reduce the throughput of your network, affect the performance, and the network is not gonna be functioning properly. Therefore, multiple access protocols are required. They are indispensable in our computer networks, in our mobile networks, in all networks basically. To decrease what? Collision, and avoid what? Crosstalk. Crosstalk interference. Crosstalk means when two people comes together and talk at the same time. We want to eliminate this, to prevent this. We don't want this to happen. This is a crosstalk. This is interference, inter-user interference, inter-device interference. So multiple access are protocols, rules, which are required to decrease collision between the devices that want to talk to each other, that want to access the medium. This is why we need multiple access, and this is how it is. So let's start with the random access protocol. Random access protocols, what are these? In this kind of protocol, all stations have the same superiority in that no station has more priority than another station to send data. Any station can send data depending on the medium state, idle or busy. So all these stations randomly talk with each other and send their data over the channel. Now, how do they send their data? They basically first sense the channel, see if it is idle or busy, if there is signal or not. If it is idle, no signal, they transmit. Now, the signal might be, the channel might seem to be idle for two receiver or two devices at the same time. And assuming the channel is idle, two devices will start talking and sending their messages at the same time, and this will result in collision, causing collision between the packets, and therefore the two receiver will lose their data. That's the problem in random access protocols. But what's the advantage? The advantage, you don't need organization, coordination. They automatically send, they just by themselves listen, see if the channel is idle or not, and receive. If it's idle, they send. If it's busy, they back up, and so on and so forth. So the coordination, the management, the organization is little, which means that the signaling overhead is little here. And signaling overhead is very important to reduce in computer networks, because if you use too much of it, you reduce the throughput in your network. In a random access method, each station has the right to the medium without being controlled by any other station. There is no master node to tell you what to do. That's one of the key properties of random access. If more than one station tries to send, there is an access conflict and the frames will be either destroyed or modified. Example on random access protocols, we have the Aloha protocol, carrier sense multiple access protocol, carrier sense multiple access collision avoidance protocol, and carrier sense multiple access with collision avoidance. There is collision detection and collision avoidance. They are different, and we will see in the following lectures how they are different. Now, this is regarding random access protocols. What about controlled access protocols? In controlled access, the stations consult one another to find which station has the right to send. So basically here, in random access, there is no master node that controls the stations and tell them when to send, when to transmit, when to talk. But here in controlled access, you must take permission from a master node, central node, before you start sending or transmitting. A station cannot send its data unless it has been authorized by other stations. This is what it means, this is what we mean by controlled access protocol. Example on controlled access protocols, we have reservation protocol, polling, and token passing. What's reservation? You basically, the transmitter, any device that wants to send its data over the channel, make an appointment, reserve a seat from the master node, tells him, I'm gonna send my data at this time, so could you please free, or if is there an empty slot or an empty space for me to send my data? It's like someone booking a room in a hotel. Like you need to reserve first. Polling is also kind of controlled access mechanism, like voting. Who has the right to send? The one with the most votes get the right to send. And token passing. There is a token, one flag, one ID, and this one ID can be with just one device at a time. The one who has the ID has the right to send. So all these are controlled access mechanisms. The main goal, of course, to reduce collision and make sure nodes can talk without interference. This is always, this is the main goal of multiple access. A good multiple access technique is a technique that can, 1, prevent collision, 2nd, make full utilization of the bandwidth, of the available bandwidth. So some of these techniques might reduce the collision, but unfortunately they don't make full utilization of the bandwidth. Why full utilization of the bandwidth is needed? Because we always, in most cases, we will always have more devices than the resources we have in our hands. When I say resources, I mean time, frequency, code, and the space. These are the resources that any node needs in order to send its data. Think of these resources like the carrier, the buses. Let's say you have stuff, you have items, you have cargo you need to ship. You cannot ship it without a car, without a plane, or without a ship, or without something that carries your data. So these things that carry your data, they are the resources. In cellular network, in computer networks, in wireless, the resources that carry our data, that we need in order to send our data, are time, frequency, code, space, and those are the main resources. Without them, if we don't get a frequency, we cannot send our data. If we don't get a time to send we cannot send. Here, because of this trade-off process between the number of devices who are requesting to access the channel and send data, because these devices are used by customers who are operating and running multiple applications and multiple apps and services. And we this trade-off, this thing from one hand, and the other trade-off is the available resources. It's the network resources. Of course, always, in most cases, the network resources are less compared to the number of devices and the needs of the devices and their requirements. Therefore, a good network is a network that can manages this in a way that satisfies the user's request, but still utilize the bandwidth very efficiently. When you have more devices requesting your resources than the available resources, you need to come up with novel techniques and novel methods that can serve more devices than the resources you have available for them. And this requires really huge intelligence and uh, smart engineers who can come up with methods and techniques that can make this possible. Until now, nobody has come up with a groundbreaking technique that can serve more users than the currently available resources. They all the techniques are limited by the available resources, which is a bottleneck for our networks. So the third kind of protocols is the channelization. This one name also people in the wireless industry, in the mobile industry, they call it scheduling. We have scheduling, which is channelization in computer networks. If you want to understand both people, you need to understand their terms. Channelization is not used in the mobile industry. It's not used by Huawei, Ericsson, Nokia, and Qualcomm. They don't call it channelization. They call it scheduling. They call it scheduled multiple access. Scheduling from scheduling. And channelization is a multiple access method in which the available bandwidth of a link is shared in time, frequency, or through code or antenna between different stations. Example on protocols using channelization, we have the FDM, frequency division multiple access. What's the frequency division multiple access? You have different frequencies with different bands, and you assign each band to a device to talk to other devices without interference. So each one is running and using certain band. Even if they talk with each other at the same time, they will not cause interference to each other. How? Because they are sending at different frequencies. If they send at different frequencies, there will be no interference. This is different from having a group of people in a room talking to each other. The only resource we have is time in this case. You need to coordinate and organize and schedule your time so that nobody interferes with the other. But in wireless, in systems based on signals in the air, you can transmit signals exactly at the same time and still not interfere with each other. How? If you assign them different frequencies. And this is what FDMA does, frequency division multiple access. You divide your spectrum into bands, into chunks of frequencies, and each user, each device will get assigned to a single frequency. And this frequency will be just for the transmitter and receiver, the ones who want to communicate with each other. If another device wants to communicate with another device, you allocate another frequency band for him, so that all the devices talk at the same time but without interference. This is FDMA. TDMA it says that no, divide the time here, like mobile telephony networks, divide the time. So they divide the time so fast that multiple persons talk to each other over the phone, and they don't feel that the time is shared with other persons, because the switching speed is extremely fast. So this is what we call time division multiple access. So at each frequency, if you have two frequencies and each frequency can serve one user, with TDMA, if you use it with each frequency, you can serve 10 users on each frequency, and all of them talking and not interfering with each other. CDMA, if you run out of frequency and you run out of time and you want to serve more devices because you have more devices requesting to access your data, you can use code division multiple access. So code division multiple access, what does code division multiple access do? It basically assigns codes for each device to use it so that it doesn't interfere with the others. Think of this code when you multiply your data. Let's say a device that has data, and before it sends the data to the channel, it multiplies it or processes it with a certain code. Once the data is multiplied or manipulated by this code, think of this like converting your signal or message into a new language that's only understandable by the device who has the same code as the transmitter. Once the device uses this code, it will be able to understand the language that the transmitter uses to contact him. So let's say you use code 1. Code 1 basically converts your data to a language that call it X language, whatever it is. And once the receiver uses the same code, also tunes to this X language. Anybody who doesn't have this code will not be able to understand what the message is. You cannot understand what's going on unless you use the same code. And these codes are shared carefully to be available only to the intended receiver, not any other party, third party node. This is CDMA, and OFDMA is a combination of FDM and TDM, but in a scheduled, structured, organized manner that makes it possible to make the transmission much more efficient than using TDMA alone or FDMA, because there is overlap between the packets and the symbols here. And the fifth one is NOMA. NOMA is non-orthogonal multiple access technique that can serve more devices than the available resources. Here you multiplex the users in the power domain. So in this case, the users are using the same frequency, same time, same code, and same space, same coverage. But the receivers can still decode their own message successfully without interfering with other receivers by multiplexing the power domain, which is one of the most smartest and most difficult techniques to implement. This technique is not yet implemented in computer networks, is not yet used in wireless or mobile. Many, just maybe few, like there is one technique that's close to it used in 4G advanced, but as far as I know, this is not yet implemented. People are trying to improve it. It has some problems right now. So maybe in the future they will be able to solve the problems associated with this technique, and maybe make it available for 6G or Wi-Fi 8 or 9 in the future. I don't know, but like researchers are working on it. So now let's go back and talk about these techniques one by one, starting from Aloha. So in the next video, we'll start explicitly and focusing just on this technique called Aloha, which is a random access protocol procedure that's used in wireless network. We want to study its properties and what it does, and the features of it, and the performance, and whether it's good or not, and the protocols that are built on top of it.